All right, guys, so I want to go over how to do some of these as an example for you. So let's look at number one first on this side. So the first thing we're looking at is how many elements are here, and we have two distinct elements. We've got there's one, the AG, and then the S, two capital letters. So because we have two elements, it's a binary compound, only two elements. So we're gonna name the first element. So AG is silver. All right. And then we take the second element, the non-metal, which this case is sulfur. So originally, we'll put the original one up in red, right? So originally it was sulfur, right? But what we do is we're going to drop that ending. So we're going to get rid of this UR, and we're going to replace it with the letters IDE. Right. So if we rewrite it together as one final answer, right, Ag2S is silver sulfide. All right. So let's look at number four. If we look at number four, all right, again, it's another binary compound. We have two elements. We have Be and we have O. All right. So Be is beryllium. And then oxygen, again, we'll do in two parts. So O is oxygen. Okay. We're going to drop that ending. So in oxygen, it's the YGN. We get rid of it. Right? And then we replace it with IDE. So we have ox and then the IDE, beryllium oxide. All right. Let's look at the next one. So let's look at number five. So in five, if we underline it, we have one, two, three capital letters, which means this is a non-binary compound. This is going to use our polyatomics. So when we use our polyatomics, we still name the first element just like we've done before. So Ca is calcium. And then the polyatomic, we don't do anything to the name. We just name it as it is. So if we look at the, sorry, misplaced it. If we look at our polyatomic list, oh, SO4 minus, or SO4 is sulfate. So we're just going to write calcium, and then we're just going to write the word sulfate. No ending is being changed. It just is exactly what it is. Okay. Let's try one more. All right. Let's try number nine. All right. One, two, three distinct elements. So we have a polyatomic. K is potassium. All right. We look on our polyatomic sheet. All right. We look for, hey, what's the name of our polyatomic elements? You look for NO2. All right. We see it right here. All right. NO2 is nitrite. So we come back over to here. Oh, sorry. Mm, yeah. So potassium and then nitrite, we just write nitrite. Again, no changing. If it's not a or if it's not a binary compound, if it is a polyatomic ion, all right, no changing of the endings. All right. Let's look at two at the bottom. All right. These are to go the other way. All right. So let's look at number 11. So in 11, we're going to write out the formula. So Calcium is easy. So we write the symbol for calcium, which is Ca. All right. And then for chloride, the symbol for chloride, well, chloride was originally chlorine. So that's Cl. Then we look for their charges. Calcium is a group 2 element, so it's got a charge of +2. Chlorine's got a charge of -1. We do our crisscross method where we bring our charges down and drop the sign. So we get Ca1, Cl2. We don't really write the 1, so we can rewrite this as CaCl2. Let's look at another one. Let's look down at 14. So in 14, we have strontium, so that's the symbol Sr, and oxide is the symbol O for oxygen. Their charges are +2 and -2 respectively. Because the charges are the same, they will cancel each other out. We can just write Sr. All right. Now, let's look at two of them that involve polyatomics. So let's do 10 and then 12. So at number 10, we start with sodium again. So sodium symbol is Na. All right. And then hydroxide, if we look on our polyatomic sheet and we look for the polyatomic ion hydroxide, hydroxide is right here. So it's OH and it has a charge of -1. So we're going to write Na, and then we're going to write OH. We're going to write its charge, -1. Sodium's in group 1, it's +1. And because the charges are the same, they cancel each other out. We get NaOH. Let's look at 12, boron perchlorate. So we're going to write symbol for boron, which is B, right? It's in group 13, so it's got a charge of +3, right? Perchlorate, there's no element perchlorate. Perchlorate is a polyatomic ion, right? So we look on our polyatomic ion sheet, all right? We look for perchlorate. There it is, ClO4 -1. So we're going to write that out. ClO4 -1. Now, when we crisscross here, we have this 3. This 3 goes on the outside. So we have not this, all right? This in red is wrong. We wouldn't want to write this. Because this is 1 boron, 1 chlorine, and 43 oxygen. Like, that's definitely not the right answer. We want to write this, all right? We want the answer that's in orange. We want the B, and then we want groups of chlorate. How many groups? We want 3 groups of chlorate. So you put the ClO4 in parentheses.